All right, let's talk about scientific notation. So again, something super helpful that you're going to use in your science classes if you take chemistry or biology. Scientific notation is used, you write this out really fast. Scientific notation is just a way to write really small or really large numbers. So instead of having to write something like 42 billion, instead of having to write all of that out or a really small number, we found a way to kind of condense it down using scientific notation. So scientific notation is in the form a, so some number, times 10 to the n power. And so this a here is going to be between 1 and 10. The other way you might see this written is that a is between 1, so it could equal 1, but it has to be strictly less than 10 because we want it to be a single digit number. So it could be something like 1.5, and it's usually going to have a decimal. But the number in front of that decimal should be a single digit number. So we're not going to have 10, 11, or 12. Those aren't considered scientific notation. And this n, this exponent here, is going to be an integer. So it's going to be one of those numbers that's a whole number. So like -2, -1, 0, 1, 2, and so on. So it could be positive or negative, but it does have to be a whole number. And some examples here. Something like 3.19 times 10 to the 20th. And like we'll see, this 10 to the 20th means that this decimal is actually 20 places further out to the right. So instead of having to write all of those zeros, we're just going to write it as times 10 to the 20th and kind of reduce it down a little bit. Another example would be 1.34 times 10 to the -12th. This means that this decimal is actually 12 places further to the left. So positive or negative indicates which direction the decimal is actually going to be in the actual number. And one thing I just want to write here that we talked about, there is always one non-zero digit before the decimal. So it has to be 1.5, 2 point something, 3 point something, 4 point something, up to 9 point something, but we can't have a 10 here and we can't have a 0. Has to be a single non-zero digit. All right, so first thing we're gonna do is we're gonna go from scientific notation to standard notation, which is just like regular numbers. So writing scientific notation numbers in standard form. And I think the book goes through and does it the other way first. I like to do this one just because I think it makes more sense. And then once you have this down, it's easier to go in the other direction. So what we're gonna do is, let's say we have our number here, a times 10 to the n. If n is positive, so if we have a positive exponent, we're going to move the decimal to the right n places. And if n is negative, we're going to move the decimal to the left n places. So I feel like this is pretty intuitive compared to going from standard form to scientific notation. On a number line, positive numbers are to the right, negative numbers are on the left side. So negative n, go to the left, positive n, move the decimal to the right. So let's go ahead and try some examples. And we'll just do a couple because for the most part, these are all going to be the same kind of thing. You're either moving the decimal to the left or right. So we want to write in standard notation. So again, standard just means normal. A normal number is without scientific notation. So let's go ahead and try a couple of these. Let's try 8.7 times 10 to the 5th. So again, we're going to take our decimal and we're going to move it to the right 5 places. And so if we do that, what I'm going to do is I'm going to write down the 8.7 and I'm going to move it to the right using kind of like little, I don't even know what I call these, like semicircles, just showing our places to the right. So we're moving at 5 places. So this is 1, 2, 3, 4, 5. And so we're going to fill in any of these empty spaces with zeros. And our decimal's all the way at the end, so we don't need to write it. So we have 8, 7, 0, 0, 0, 0. I'll just throw in a comma there, and we have 870,000. Let's go ahead and try one with negative exponents. Let's try negative 5.27 times 10 to the, let's do negative 4. So this is saying move it to the left 4 places. And it doesn't matter if this number that we're starting with is positive or negative. If it's negative, you're going to keep it negative. If it's positive, it'll stay positive. So I'm just going to write that negative right here. And I'm actually going to write, I'm going to give myself a little bit more space because we're moving to the left. We're taking our negative 5.27 and we're taking our decimal and we're moving it to the left 4 places. So 1, the negative doesn't count, that's paired with the 5. So it's 1, 2, 3, 4. Fill in zeros wherever you see these spaces. What I'm going to do first is put the negative in the front. The decimal is going to go in the front now. We can't just put a decimal here by itself, so I'm going to put 0 point. And then we're going to have 0, 0, 0, 0, 0, 0, 5, 2, 7. And if we were to double check, our number is still negative, so we're good. And we took our decimal next to the 5 and moved it left, 1, 2, 3, 4. Always double check your answers with these. It's really easy to move it 4 or 5, especially when you have larger numbers. So when you're moving it, let's say 9 or 10 times, it's easy to miscount or miss putting in a 0. So make sure you always double check that you moved it the correct number of places. Let's just try one more. This one is 7.004 times 10 to the 0. So this one isn't one of the typical ones. Normally you don't see 0 exponents because it doesn't really tell us much. This is saying move the decimal left or right 0 places. So if we do that, it's not going to move. So we're just going to keep 7.004. So this one, it just happens that the scientific notation is the same as the standard notation. The other way to think about this is, what is 10 to the 0, or any number raised to the 0 power? 1. And 7.004 times 1 is still 7.004. But typically you don't see these zeros. You'll usually see ones where it's a positive or negative number. Okay, now let's talk about writing numbers in scientific notation. And I'll say writing standard form numbers. I keep combining words as I'm writing them. Standard form, put that in parentheses, numbers, because they're just regular numbers in scientific notation. And so this one I am going to write out kind of a whole process. It's going to sound kind of complicated, so we'll just take a look at some examples. Okay, so this means we're taking a number like one of these standard form numbers up here and going backwards to scientific notation. First thing we're going to want to do is figure out where the decimal needs to be. So we're going to position the decimal point after the first non-zero digit. And so what that means, if we look back up at this one here, the first non-zero digit is 8, so it'll always go right after that. In this one here, the first non-zero digit, if you just go from left to right, is the 5, so it went right after the 5. And we'll see some more of those. Second thing we want to do is determine how many places we moved the decimal, or how many times we need to move it. So determine how many times or how many places to move the decimal. So like I was saying again up here, we know it has to go after the 8. Right now it is after, it's at the end, so we have to move it over 1, 2, 3, 4, 5 times. We have a 5 right here. And then our last step, this one's broken into 2 different parts. We need to determine the sign of the exponent. It's not always going to be positive, it might be negative. So there's a couple ways you can remember to do this. One is that a negative number, if you move the decimal, if you have to move it to the right, then you have a negative. And if you have to move it to the left, you have a positive exponent. I don't like that way just because it's kind of counterintuitive. Normally we think left is negative, right is positive, but it has to be the opposite because we're going backwards. So the way I like to think of this is if you start with a really large number, then you're going to have a positive exponent. And if you start with a really small number, then it's going to be negative. And most of the time, I'm just double checking my answers at the end to make sure that it's going in the right direction. And so let's go ahead and look at some examples of what I mean by that. And again, we'll just look at a couple of examples because it's all going to be the same. We're just working with either really large or really small numbers. And so we're told to write these in scientific notation. Number 1, we're given, let's do 5,870,000. So first thing we're going to do is figure out where the decimal needs to be. So going from left to right, our first non-zero digit is 5, and so we want the decimal to be right here. Right now it's at the end, so I want to figure out how many places we have to move it over. So I'm going to count 1, 2, 3, 4, 5, 6, and it's going to end up right there. Move that one. So this is 6 places. And now we're going to get rid of any of the zeros that we don't need. So we have 5.87, and we don't need all of those ending zeros. And then we're going to have times 10 to the It's either going to be a 6 or a -6. And so one way I like to do this is think about which direction the decimal would move if we went backwards. So +6 is going to tell us to move it to the right 6, which is what we want. If we had a -6, it would tell us to go to the left, which is not where we want the decimal. So it has to be +6. The other way is we started with a large number, so it's going to be positive. All right, let's try one more of these with some smaller numbers. So 0.057102. So again, figure out first where the decimal needs to end up. So our first non-zero digit here is, again, this 5, so it should go right here. And it has to move over 1, 2 places. And so if we get rid of those leading zeros because we no longer need them, we're going to have 5.7102. 5.7102. We need any zeros in between the numbers, but you don't need any that are leading or ending because they don't change it, change our number. And now times 10 to the, I'll put the 2 up there, but if we had a +2, this would say take our decimal and go to the right 2. We don't want that. We want to take our decimal and go to the left 2. So it's going to be times 10 to the -2. And again, we started with a small number, which is why we put a negative exponent. All right, so now the last thing we want to do here, we're going to do a couple of different operations with scientific notation numbers. First thing we're going to do is multiply numbers in scientific notation. And I remember doing this back in chemistry in my undergrad, and I remember seeing this and thinking that it was kind of weird, and there were different rules that I had to memorize, but it's actually just using all of the exponent rules that we just talked about. So what we're going to do, because we're going to have numbers in scientific notation like this, we're going to multiply the numbers in the front first. Multiply the numbers in the front. And then for the variable, or not the variables, the tens in the back, we're going to use our product rule with the exponents. And so what I mean by that, let's go ahead and look at some examples. We're told to multiply, write our answer in scientific and standard notation. So we're going to write it as an actual number, and we're going to condense it down and write it in scientific notation. So number 1, well, again, we'll just do a couple of these. Let's go ahead and do 3 times 10 to the 5th, in parentheses, times 3 times 10 to the -2nd. All right, so now for this one, what we're going to do is we're going to multiply the numbers in the front. So 3 times 3 is 9, times 10 to the, we're going to use our product rule and add the exponents. So 5 plus -2 is 3. And so we're going to have times 10 to the 3rd. And now This one's already in scientific notation actually, because 9 is a single digit number. And so we're gonna leave this as our scientific notation. Our standard notation, we wanna take our decimal, so the 9 has an imaginary decimal there. Move it to the right 3 places, so 1, 2, 3. And then 10 to the third, we're gonna add in those 3 zeros, and we get 9,000. All right, so that one was pretty nice because it was already in scientific notation for us. Let's go ahead and try one more. Let's go ahead and do 3 times 10 to the 5th times 5 times 10 to the negative 2nd. All right, so now what we're gonna do is we're gonna multiply the numbers in the front first. So 3 times 5 is 15. Add the exponents, so 5 plus negative 2 is 3 again, so times 10 to the third. We don't want to box this answer because this isn't in scientific notation. This isn't a single digit number. And it's not in standard notation either because it has times 10 to the third. So first thing I'm gonna do is I'm gonna go to standard notation first because it's actually a little bit easier than trying to fix this into scientific notation. So we'd have to figure out what to do with our exponent. And so what I'm gonna do is I'm gonna put it into standard notation. I'm gonna take the decimal and move it to the right 3 places. And we get 15,000. There's our standard notation. Scientific, I'm gonna take the decimal now that's all the way on the end, and we wanna put it after the first non-zero digit, which is right here. And so we wanna move it over 1, 2, 3, 4 places, and we're gonna have 1.5 times 10 to the, let's check to see if positive 4 works. That moves it to the right 4, which is what we want. So again, what I like to do is go to standard notation first. If it's not already in scientific notation, put it back in scientific notation afterwards. All right, so that's multiplying. So remember, multiply the numbers, add the exponents. Now, if we're going to divide numbers in scientific notation, it's going to be really similar. We're going to divide the numbers in the front first. So divide numbers in the front. And then, since we're dividing, we're going to use the quotient rule. With the exponents. All right, so again, just a couple of examples, and then we'll be done with scientific notation. So for these, we're told to divide, and then again, write the answer in scientific and standard notation. So number 1, 4.8 times 10 to the second over 2.4 times 10 to the negative third. So first thing I'm gonna do here is divide the numbers in the front. So 4.8 divided by 2.4 is a nice even 2. Times 10 to the, we wanna subtract our exponents because we're using our quotient rule. So now this is one where we can't really use the move around the term. So we don't really wanna move this negative third up to the top. You can, it's gonna look a little bit uglier now that we're dealing with scientific notation. So what I'm gonna do is I'm gonna write the subtraction off to the side. Just be really careful with your signs. So 2 minus -3 means that we're gonna do 2 plus 3, which is 5. So 10 to the 5th. And now this is already in scientific notation because we have a whole number here and it's a single digit. Now we're just gonna take our decimal, move it to the right 5 places, fill it in with zeros, and we get 200,000. All right, so that first one wasn't too bad. Let's go ahead and try just one more of these. Let's put this on a new page here. Okay. Number 2, 40 times 10 to the -5th over 2 times 10 to the 3rd. So now they gave us a number that's not in scientific notation. If you notice the one on top, 40 is not a single digit number, so it's technically not in scientific notation right now, but let's go ahead and divide anyway. So if we divide the numbers in the front, 40 divided by 2 is 20. And now if we use our quotient rule and subtract, -5 minus 3 is -8, so times 10 to the -8. I'm not going to box this answer because 20 is not a single digit number, so it's not in scientific notation. So first thing I'm going to do is I'm going to put it into standard notation, and we're going to take our decimal, move it to the left 8 places, so 1, 2, 3, 4, 5, 6, 7, 8, all the way over there. So it's going to be 0.000000 to 0. We don't need the final 0 there. So 0.12345 1, 2, 3, 4, 5, 6, 2. And notice how the number of zeros here doesn't always match the exponent. That's because we had to move it past the 0 and the 2 before we could start adding in those zeros. So be careful. Make sure you don't just add the number of zeros based on the exponent. Okay, now we have our standard notation. And if we want to put this back into scientific notation, we want the decimal after the first, I'm going to write this number down actually really fast. We want the decimal after the first non-zero digit. So we want it to be right here. So I'm going to move it over 1, 2, 3, 4, 5, 6, 7 places. So it's going to be 2 point nothing, so just 2 times 10 to the, now we want to figure out if it has to be positive or -7. Positive 7 would mean go to the right 7. We don't want that because that would give us a really big number. We want this really small decimal, so 2 times 10 to the -7. Cool, and so that's doing multiplication and division with scientific notation. We're not going to look at addition and subtraction. That one's going to be a little different. But that was a little introduction to scientific notation. We're not really going to see it a whole lot more in this class, but like I said, you will see it in your science classes. Okay, so next time we'll take a look at polynomials. So we're going to be adding and subtracting, multiplying and dividing them. And then once we're done with those, we'll jump into chapter 6, which is our final chapter. And that's where we'll get into factoring, which is really important.